All right, example 4, we're asked to find the area bounded by y equals the square root of x, y equals x minus 2, and y equals 0. All right, so this is a little different. There's 3 functions here. So we need to graph this and then take a look and see what it is, what is the area that we're actually looking for. So we're finding the area bounded by these 3 functions. Here's y equals the square root of x. Here's y equals x minus 2. And then here is y equals 0. Right, so it's this area that we're looking for, this total area. Now, if we think about this in terms of top and bottom functions, we can see that there's really 2 areas that we need to be concerned with here. Right? As we move from the left to the right, in this first section, our top function is the square root of x, and a bottom function is y equals 0. Till we get to here. At this point, our top function is y equals the square root of x, and our bottom function is y equals x minus 2. All right, so we have to break this have to break this interval of x values up into from here to here, and then from here to here. All right, and we really need to figure out exactly what those are. I can estimate them based on this graph, but I really need to think hard about, okay, well, here this is the square root of x, so I know that this is x equals 1. Right? This is the place at which x minus 2 intersects the x-axis. So it's when x minus 2, it's when these 2 functions are equal to each other. It's where they intersect, which of course is at x equals 2. And then here I have, this is where the square root of x intersects x minus 2. All right, so I have to really solve that for x. Turns out that's also x equals 4 there. So I clearly misspoke here. I don't know what I said, but I wrote down the wrong thing. This is clearly not at x equals 1. That's clearly at x equals 0. And I either misspoke and miswrote that, or just miswrote it. I'm not sure. But we have x equals 0, x equals 2, and x equals 4 as our x values. So when we do it this way, we're going to go, okay, well, the integral from 0 to 2 of square root of x minus 0 plus the integral from 2 to 4 of the square root of x minus 2. Now, of course, this is x to the 1/2, so we're going to find the antiderivatives. Evaluate this function here at 2 and 0 and do the subtraction. Evaluate this function here at 4 and 2 and do the subtraction. And once you work through that arithmetic, you'll come out to 10⁻³ square units. All right, so take a look. There's a different way that we can do this problem. Rather than integrate from left to right, in which case our bottom function changed when we got to x equals 2. It went from y equals 0 to y equals x minus 2. We could integrate from the bottom to the top. So we could integrate with respect to y. And if we do that, we see that the right function is always x minus 2, and the left function is always the square root of x. All right, so if we do it this way, we can do it in as one integral. We can go from y equals 0 to y equals 2. The only catch to doing it this way is that we need to rewrite these functions in terms of y. right? So we have to, if we're going to do it this way, we have to solve each of these for x. So here I have x equals y plus 2, and here I have x equals y squared. And now I can integrate from 0 to 2, y equals 0 to y equals 2. And I can do it as just one integral. So I'm going to integrate from 0 to 2. Notice that I have dy here because this is y equals 0 and y equals 2. My right function is y plus 2. My left function is y squared, so I'm going to do the right minus the left. Find the antiderivatives, evaluate at 2, and evaluate those at 0. Do the subtraction. Now, it's worth noting, it's probably obvious, but it's worth taking note, that regardless of how I do this problem, the area here is the same, right? The way that I evaluate that area doesn't change the area itself. So if I got 10/3 square units here, I should also get 10/3 square units there. You know, there's a give and a take here. This integral is easier. I only have to find 1, and I can use y equals 0 as 1, so that makes this arithmetic a lot simpler. If you work through this arithmetic, you'll see that it's not as simple. But I do have to solve these for x first, and I have to think about it in a little bit different way, and it can be harder to think about doing the integrals this way. But we do want to familiarize ourselves and open ourselves up to the possibility of approaching it that way.